Alright, so we're going to finish up the rest of this test with the pre-response sections. We're going to go one question at a time and then we'll move on. Number 1, find the value of x such that the lines are parallel. Well, first we have to recognize what relationship these two angles have. From 8x minus 4 to 60. Notice that these are on alternate sides of the transversal, and they're both on the inside of the parallel lines. So this is alternate interior. Alternate interior. We know that all alternate interior angles are congruent. If they are congruent, therefore we know that 60 must equal 8x minus 4. And from there we can simply solve. We add 4 to both sides. And we get 64 is equal to 8x. Divide by 8 on both sides, and x is equal to 8. Notice that that is what I asked for. Just be careful that yours matches up. Number 2, find the value of the missing angle, show all work. Notice that the 115 here is the exterior angle, not an interior angle. For any relationship like this, we need to remember that angle 1 equals angle 2 plus angle 3. The exterior angle is equal to the sum of the two non-adjacent interior angles. Non-adjacent means not next to. So if we plug in our numbers, 115 is equal to angle 2, we'll call x, plus angle 3, which is 50. We subtract 50 from both sides, and we got that x is equal to 65 degrees. Be sure to throw that degree sign on there and make sure you include your units. Moving down to number 3. On the diagram below, appropriately mark all congruent angles and congruent sides. Well, this is easy. We just need to match up our letters. W goes with G. We'll go 1 tick mark. V goes with H. And U goes with I. Notice that they are not all the same. That's why we have to do 1 set, 2 set, and then 3 set. Next, we need to do the sides. WV goes with GH. VU goes with HI. And the last one, WU, must go with GI. On to number 4. Number 4, find the distance between the 2 points. This is a straight application of the distance formula. So first we're going to write in our distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Make sure that your square root symbol goes over the entire expression. Label your points x1, y1, and x2, y2, and then we simply plug and chug. So we get that the distance is equal to the square root of x2 is 2 minus x1 is 3 squared plus x2, or y2, excuse me, is 1 minus 5 squared. Carry it down, make sure you don't drop the square root symbol. 2 minus 3 is a negative 1, keep it in parentheses, plus negative 4 squared. Remember that if you have a negative 1 squared, it's going to be negative 1 times itself twice. A negative times a negative is going to become a positive, so it's going to become a positive 1. So the distance is equal to 1 plus negative 4 squared is 16. So 1 plus 16. So D is equal to the square root of 17. Now if you have a calculator, you can plug it in to get your decimal version. Although it's not necessary to do so. Square root of 17 is approximately 4.123. Number 5 will be a bit of a long problem. Label the points. First off, we need to talk about what problem this is. We have 3 similar triangles here. They're all right. So 3 similar right triangles. It's going to help if we label all of our points. So we'll label it A, B, C, and D. You'll notice we have the large triangle ABC. We have the medium triangle ABD. And we have the small triangle BDC. First step we're going to do is draw our 3 triangles. Excuse me, that's the wrong color. So the big triangle was red, followed by the medium one, which is green, and the small one, which is blue. We want to label our right angles first. So the right angle for the red one is at B. The right angle for the green is at D. And the right angle for the blue, also note, is again at D. If we look at the red triangle, it doesn't matter which letter we pick first, although you can kind of see that A is further away than C. So A will go at the top, C will go on the bottom. Next we want to look at the green. Green, the options are either A, B, or D, if you look at the triangle right here. We've already used D for the right angle. We have A and B left. Well, B is in the spot where the D has taken it, so the only option is to plug in A to match up with the red triangle from before. That leaves us with B, which must go down below. If we look at the blue triangle, my choices are D, B, and C. Once again, we've already used D for the right angle. B would be in the D spot, so that's not going to work, so the only one that would work is C. Match it up with the red triangle again. That leaves B, so B must go up top. At this point, we take our values and we plug them in wherever they are applicable. So you see that AD is 8, so that's right here. That's the only spot for AD. DC is 4, that goes right here. And BC is X. And there's X, are there any other BCs? And there's an X. Now, we want to look for a set where we have two matching parts, so two matching pairs. Notice that the green, the 8, doesn't match up with the red or the blue. The blue, we have the 4 and the X that match here and here, but we need something to match with the X over here. That is AC. Notice that AC is the entire length here, and it's going to be the 8 plus the 4. So AC is going to be 8 plus 4, so it's going to be 12. If we look at the red and the blue triangles, we now have a complete pair. We have two pairs. We'll ignore the green one. We'll go big to small. So red, 12 to X from the blue, right here, equals X from the red over 4 from the blue. At this point, because there's a fraction with the equal sign in the middle, we can cross multiply. Remember that X times X is not 2X, it is X squared. So X squared equals 4 times 12 is 48. To solve for X then, we do the inverse, which in this case is the square root. So by using the square root of both sides, the square and the square root will cancel, and we get X is equal to the square root of 48. Once again, you may leave it like that, otherwise you can type it in and solve it as a decimal. As a decimal is approximately 6.92. Number 6 asks us to find X for the parallelogram, DEFG. We have to remember that for parallelograms, the opposite angles, that is the angles furthest away from one another, are congruent. That means that G is congruent to E, and it also means that F is congruent to D. And you can see that simply by looking at them. The two acute angles are congruent and the two obtuse angles. If they're congruent, that means they're equal, so all we need to do is set 3x plus 11 equal to 5x minus 9. At this point, you can pick any term to switch sides. I'm going to switch to 3x, so I'm going to subtract. 3x minus 3x will be 0, so it drops out. 11 equals 2x minus 9. We add 9 to both sides. 20 is equal to 2x. And the last part is divide by 2, so x equals 10. Moving down to number 7. Moving down to number 7. Find the area of the following figure. Well, first we need to know what type of figure that is. Notice that there is one set of parallel lines and only one set, so therefore this figure must be a trapezoid. And we have a formula for the area of the trapezoid. Don't forget to use your formula sheet on the exam. The area of the trapezoid is 1/2 B1 plus B2 times h. B1 and B2 are the two bases. H is the height. Remember that the height must always be perpendicular to the bases, which it is here. So we plug in our values. It's 1/2. B1 is 10. B2 is 5. The height is 6. So this is 1/2 15 times 6. It equals times 1/2 15 times 6 is 90. Half of 90 then is 45. Let's not forget our units. We're found the area, so it's going to be units squared. No units are provided, so we just have to stick with units squared. Number 8, find the area of sector PQ. Remember that the sector of the PQ is asking for the area inside the pizza slice, so the cheese, the pepperoni, everything inside. We have a formula for the area of a sector. It is area of the sector is equal to the arc measure over 360 times, we're relating it to the area of a circle. The area of a circle is pi r squared. Notice that they give us the radius, it's 4 inches. They also give us the arc measure as 110. So from here we simply plug and chug. So the area of the sector is equal to 110 over 360 times pi r squared, which is 4 squared. So the area is equal to, we can chop off the zeros because they both end in 0. Divide by 10. We get 11 over 36 times 4 squared is 16. Move it to the front, we get 16 pi. Throw that 16 pi over a 1 so we can multiply these two numbers together. There is no equal sign in the middle, so we just have to multiply these fractions across. I'll come over here. So the area is equal to 11 times 16 pi, which is 176 pi, over 36. At this point, we can reduce a little bit. Both of those are divisible by 2. So if we divide 176 by 2, we get 88. Don't forget the pi. Over 36 divided by 2 is 18. Once again, those are both divisible by 2 again. So I can get 44 pi over 9. 3 doesn't go into 44, so at this point we're stuck. We need to add our units. We're finding an area again, so it's going to be unit squared, but this time they've given us the units, it's in inches. So it should be 44 pi over 9 inches squared. Or if you want to type it into your calculator, 44 pi divided by 9 is 15.36 inches squared. Once again, either is acceptable. Moving down to number 9. Find the following arc measures. The arc measures are the degree measure of each slice of pizza in this case. Remember, there are two things that you need to look for: vertical angles and semicircles. Notice right off the bat that we have, we have one pair of vertical angles here. That means that those two are going to be the same. You should also notice that we have a semicircle right here. Semicircles are 180 degrees. Therefore, if I take 180 minus 135, I'll get what BC, arc BC, is equal to, which is 45 degrees. That means that this piece, EF, must also be 45 degrees. Then if I use the same semicircle on the other side, I have 81 and 45 taken up already. So that means I have 126 degrees already used. I need to find out what's left, so I do 180 minus 126. That leaves me with 54 degrees. So 54 degrees. To check it, the whole circle is 360 degrees, so you can add up the degrees all the way around to make sure it equals 360. Next, you want to look at your arc measures on the left. So it asks for BC. BC is right here. How many degrees? Easy enough, 45 degrees. EF. Here's EF. Once again, 45 degrees. EFB, this is a major arc. Major arcs are greater than 180, or they're a semicircle if they have to use the extra piece. So we go from E to B, but in the middle we have to go through F. So E, F, B. Do not go through the middle. EFB is a complete semicircle. Semicircles are always 180 degrees. DC. DC, we take the shortest route from D to C. Goes along the outside there, 54 degrees. And the last one, EDF, from E to F. But because there's the point in the middle, we have to go the long way because it has to go through D. So E to D, all the way around to F. Notice that this is almost the entire pizza, but one slice is missing. That slice is 45 degrees, so I'm going to use 360 for the whole pizza, minus the piece that's missing, which is 45. 360 minus 45, this is going to be, let me rewrite this. It's going to be 315 degrees. 315 degrees. Now on to the last page. Find the total surface area and the volume of the cylinder. Well, it tells you what it is right away. So we have a formula for both the area and the surface area of a cylinder. The area of a cylinder is the base, which is a circle, so pi r squared, times how tall it is, which is the height. The surface area is slightly more difficult. Remember that a cylinder breaks into two circles plus the rectangular piece that forms its sides. So the surface area is equal to 2 times pi r squared, that's for both the circles, the top and the bottom, plus the rectangular piece. Well, the rectangular piece is hard to imagine. We know that this piece side is h, because it's how tall the cylinder is. Remember that this top of the rectangular piece is going to wrap around the cylinder when it's fully closed. So we know that the distance around a circle is the circumference. The formula for circumference is 2 pi r. So if we're looking for the area of that rectangle, it's going to be 2 pi r, the length, times the width. Well, the width in this case is h. They give us the radius, they give us the height, so at this point we can just plug and chug. So it asks for surface area first, so we'll do that. Surface area equals 2 pi r squared, that's 2 squared, plus 2 pi r, which is 2 again, times the height, which is 6.5. We can type this into a calculator. Well, we don't even have to. It's not that bad. 2 squared is 4. 4 times 2 is 8. So 8 pi plus. Over here we have 2 times 2, which is 4. 4 times 6.5 is going to be 24, 26 pi. We can combine those two terms because they both have a pi. So 8 pi plus 26 pi is 34 pi. That is perfectly acceptable. Let's make sure we put some units on it. It's an area, so it's going to be feet squared. If you want to write it as a decimal, it would be 106.8 feet squared. Surface area is a little trickier. Oh, sorry, that was surface area. The volume is, oh, I'm sorry, I made a mistake. This should not be the area. This should be the volume. The volume there. So that should be a V, not an A. The volume is a little easier. Volume is pi r squared h. So the volume is pi times the radius squared, which is 2 squared, times the height, which is 6.5. So this is 2 squared is 4. 4 times 6.5 is the same thing as what we got above, it's 26. Don't forget the pi. The units, however, volume is always measured in units cubed. So this will be feet cubed. So 26 pi feet cubed. 26 pi feet cubed is equal to 81.7 feet cubed. Remember that the top and the bottom plus the side is called the total surface area. If I'm just looking for the lateral area, remember lateral means side, think football or equilateral. It's just the side of the can. It does not include the top or the bottom. It's just the side of the can. In this case, the lateral area is just the rectangle that forms when it unfolds. The last problem is going to take up some room, so let me scroll up. Whoops, a little too far. The square ABCD is inscribed in circle O. Inscribed means that it's drawn inside. If the radius of the circle is 5, find the area between the circle and the square. Well, the area between the circle and the square is this stuff right here. So in order to find the area between the circle and the square, we need to say that the area of the shaded part is equal to the area of the circle minus the area of the square, because the square has been punched out of it or it's taken away. The area of the circle is fairly easy. Notice that they gave us the radius. The radius was 5 inches. Well, the area of the circle then is pi r squared. We know that r is 5, so it's pi 5 squared. 5 squared is 25, so it's 25 pi. We'll pick up the units at the end. So the area of the circle is not bad. The hard part is the area of the square. We know that the area of a square is equal to the side squared. However, the problem is, this is an S and this is a 5 in for the radius. So S 5. We know that for the square we need to find one of the sides. Well, to find one of the sides, it's going to be easiest if we extend this line. If it's 5 from O to B, it's also going to be 5 from O to C. And you can draw this triangle down below here, or off to the side. We know that the angle will be right, since this is a square. And we know that this side will be the same as this side, because it's the top and the left side of the square. And we know that the hypotenuse will be 10. If we plug in x for both of these two sides, because they're equal, you'll notice that we can use the Pythagorean Theorem. So I can say that a squared plus b squared equals c squared. A squared and b squared are both x squared. And c squared is 10 squared. X squared plus x squared is 2. X squared equals 10 squared is 100. We need to get x squared by itself, so we divide both sides by 2. We get x squared is equal to 50. So x is equal to the square root of 50. Or, if you want to type it into a calculator, you can say that x is equal to 7.07. X here is the side of one side of the square. Now we also could have done that if we wanted to using special right triangles. Notice that we cut the square in half, so this really would have been a 45, 45, 90 right triangle if we wanted to. So we have the square root of 50. Now we simply need to find the area of the square. Well, the area of the square is equal to the side squared. We found out that the side squared, well, one of the sides is square root of 50, and then we have to square it. It turns out that that square is going to knock out the square root. The only thing that's going to be left is 50. So going back to our original equation, the area of the shaded part is equal to the area of the circle, which is 25 pi, minus the area of the square, which is 50. We cannot combine those because the 50 does not have a pi with it. So at this point, you'd have to go to a calculator. You get that the area of the shaded part is equal to 28.5. And the units, we are finding an area, so it's going to be units squared. However, it is in inches, so the answer will be in inches squared. And that's your final answer for number 11. Area is equal to 28.5 inches squared. Once again, if you have any questions, please feel free to email me or ask me any questions after school. Good luck on your test, and I hope the studying is going well.